Okay, we'll continue with the differentiation assessment mode topic, Calc 3, question 9. So there's two houses P and Q that are 900 meters apart, and there's a railway line along AC, and there is a station at C. Okay, so we have three different spots. We have spot P, Q, and R. And basically, what they're trying to do is try and figure out how to get from, basically are trying to build a a train line that will connect C to Q to P. So I mean, they have a couple of options. You can either make the train line do this and then go that way. So that's one thing you can do. Or you can just basically have two separate train lines that just go straight to the houses. Or they basically have a shared train line, and then from that shared train line they go to the separate houses. So we've got all these various options, and obviously it's an optimization question, so we're trying to probably figure out where should they put this R, where should they put that small train so that we minimize the total amount of track needed. So you can see that's what it's saying. If you pretty much ignore all the words, it says X is PR plus QR plus CR. So first of all, PR plus QR, that's pretty easy. So PR plus QR is referring to this distance here, which are equal. So that's PR and that's QR. Obviously, they'd have to be tracked there. And then plus CR. So CR is obviously just CR is just this distance right here. So first we just have to come up with expressions for those distances there. Now the only piece of information that's not on the picture is the fact that it says that B is 1200 meters from C. So this entire distance is 1200 meters. So just remember that. I'll put that on the picture here. This entire distance here is 1200 meters. Perfect. We need to first come up with an expression for x. So, and it's in terms of the angle. So it's just a bit of SOHCAHTOA. So let's come up with an expression for this. I'm just going to call this A. That's also A. So according to SOHCAHTOA, what we have is we got to use this angle in the 450 meters. So if I use this angle in the 450 meters, that's the opposite in the hypotenuse. So that's going to be sine. So we have sine theta equals opposite over hypotenuse, which means A is 450 divided by sine theta. Okay, and we also need to come up with an expression for this. Now we know the whole thing's 1200 meters, so if I can come up with an expression for that, we'll just call it B, then I can just do 1200 minus B. So this time I'll be using tan theta. So tan theta is opposite, which is 450, over adjacent, and now the adjacent side is 450 divided by tan theta. Perfect. So it even told you that. It said by forming expressions for PR, they held your hand for you. So PR is basically this one here, which we called A, and by forming an expression for BR, which basically we called B, and then obviously using BR and using the fact that the whole thing is 1200, we can come up with an expression for CR. CR will just be 1200 take B. So they really, really held your hand so you knew exactly what to do. So at the end of the day, X we know is basically 2 lots of A. So X is 2 lots of A plus RC, which is 1200 take B. And now all I have to do is replace my expression for A and B into, so A can go there and B can go there, and we've got ourselves an expression for X. So 2 times 4, A first, so 450 on sine theta, plus, okay, so that's your expression for A, plus 1200 take B. So B we agreed was 450 divided by tan theta. Now, what you guys will notice is that the answer has not got any tans in it. The answer has got cos and sine. So I think it's important for people to obviously remember that tan theta is sine theta over cos theta. And if tan theta is sine theta over cos theta, that means 1 over tan theta. So the flipped version, if you flip the left, you flip the right side. So it's cos theta on sine theta. And why is that going to be important? I hope everyone realizes that 1 over tan theta, which is what we have over here, we basically have 1 over tan theta right here. We have something divided by tan theta. So that's going to make it really easy. So let's just expand the whole thing through. So that's 900 on sine theta plus 1200. And instead of writing 1 over tan theta, because that's what we basically have, we write cos theta on sine theta. So take 450, and I'm replacing 1 over tan theta with cos theta on sine theta. Okay, that's again quite self-explanatory and straightforward. Okay, now notice the answer's got the 1200 left to the side, so we'll also leave the 1200 to the side. And then we have to ask ourselves, what do these two things have in common? What does this and this have in common? They both have a sine theta in the denominator, and I guess 900 and 450 have a 450 in common. So we can factorize out the 450 over sine theta. We factorize it out, and then we're left with, how do we go from there to there? Well, we just have to times by 2. And then how do we go from there to there? We just have to times by minus cos theta. And perfect, that is your expression for x, exactly like how they've said it. Alright, so that part was easy. We've formed an expression for x. So it's saying use calculus to find the minimum value of x. And luckily we don't have to justify the nature of the station point, which is pretty good because it's calc-free, so it would be a bit hard to do the double derivative or the sign test. So we are trying to minimize x, which is what I said before, right? What's the context of this question? That there is basically a station here, a station there, and a station there, and they basically have a very small train. They're trying to figure out how much does a small train have to travel on a common pathway before they decide to take individual pathways. Okay, so we're trying to find out the minimum value of x, aka the minimum value of the train tracks needed to get everybody from station to their individual houses at P and Q. Alright, I'll just rewrite this a bit differently to allow me to differentiate it. So I'm going to write 450 because that's a constant, and I'll just leave it as this. It's always best to leave constants out the front if you can when you want to differentiate. The reason why it's best is if you ever have y equals k times by a function and you want to differentiate it, you can just leave the constant at the front and then differentiate the function. It just lets the numbers stay small. So in this particular case, I have to differentiate this. So 1200, I'm going to leave the 450 to the side, and obviously we have to use quotient rule. Quotient rule means copy the denominator, differentiate the numerator. We should all know derivative of cos theta is negative sine theta, and there's already a negative there. So negative sine theta is positive sine theta. And then remember, guys, in quotient rule, you always have to write minus, okay? I'm also copying the denominator squared on the bottom. So what have I done? Again, for those that have forgotten quotient rule, you copy, there's basically numerator, denominator. You always copy the denominator first and differentiate the numerator minus the other way around. So now we copy out 2, take cos theta. And now all we need to do is differentiate the denominator. Derivative of sine theta is just positive cos theta. Alright, perfect. All over denominator squared. So that is x dash, and obviously, sorry, I don't know why I wrote 1200. Derivative of 1200 is 0. So that is x dash. And now all we need to do is let that equal 0. Now remember, when a fraction is 0, what part's 0? The top is 0. So all we want is this bit here to be 0. It's not 450, that's 0. It's not sine theta squared, that's 0. It's the numerator, that's 0. So what we have is sine squared theta. Take, now remember the take carries on to the entire thing, so take away 2 cos theta, and then it's going to be plus 2 cos squared theta equals 0. Now again, we have to use an identity that we've learned earlier. We've learned that sine squared theta plus cos squared theta is 1. That means, now look, you have a cos squared, you have a sine squared, but then you have a cos. Now it's impossible to just change the cos. This rule here doesn't have a rule for cos. What I'm trying to say is when you're deciding whether you have to change out for cos squared theta or sine squared theta, because there's a cos theta there, we're going to have to just rearrange for the sine squared theta and eliminate the sine squared theta. So sine squared theta is 1 take cos squared theta. So instead of writing this here, which says sine squared theta, we're going to replace sine squared theta with 1 take cos squared theta. 1 take cos squared theta. Take 2 cos theta plus 2 cos squared theta is 0. I hope everyone's okay with the using of that trig identity. And then I hope everyone realizes that this is looking very much like a quadratic. So if I add up the cos squared theta, you have a minus cos squared theta plus 2 cos squared theta. That's 1 cos squared theta. Take 2 cos theta plus 1 is 0. And if you really can't see that it's a quadratic, you can let cos theta equal c, and then you'll really realize it's a quadratic. So this is 0. And that would basically mean that what we have is, make sure I've got that all right, 2 numbers that multiply to, 1 and add up to give -2 would be, I want to make sure I've got that all correct. My expression for x is right, 452 take cos theta. Copy the denominator, differentiate the numerator, that is correct. Then minus the other way around, copy the numerator, differentiate the denominator, that is correct. I want to make sure my expansion is right, sine squared theta, take 2 cos squared theta up. This is important. So what we actually have over here is not a 2 cos squared theta, we just have cos squared theta. Alright, that actually makes it so much easier. Alright, so I made a silly mistake there. That makes it so much easier. I made an expansion mistake in my expansion. So you'll realize that it's actually just normal cos squared theta. That makes it so much easier. Then we don't have to do everything that I said before. We just have to realize that, you have a sine squared theta plus a cos squared theta. And straight up, sine squared theta plus cos squared theta is 1. Makes it even easier. 1, take cos 2 theta is 0. And that basically means that cos theta is half. Okay, so important to not make the silly mistake that I did before. By the way, I just want everyone to realize, how did I know I had a silly mistake? Okay, how did I realize that I made a mistake? I realized that I made a mistake because this is the expression that I had ended up with. I had ended up with, I'll write it on the side, c squared take 2c plus 1 is 0. Alright, as soon as I saw that, I realized I made a silly mistake because look, that basically means c take 1 squared is 0, which basically means c is 1, which basically means cos theta is 1, which means the angle is 0. And that's, I saw that happening. I saw the angle being 0, and I just thought, how can the angle possibly be 0? If the angle is 0, it just doesn't make sense, right? The angle at least has to be, it even says that the angle is somewhere between 0 and pi on 2. So that's how I realized that I made a mistake, and that's what made me stall a little bit and see if I've differentiated correctly. I did differentiate correctly, then what I did wrong was expand properly, okay? Anyway, cos of what gives us a half? Now remember, the angle is between 0 and pi on 2, so that would be cos of 60, aka pi on 3. Alright, we don't need to justify that it's the minimum, and we simply need to find the minimum value of x. So we already have an expression for x, we just have to sub theta equals pi on 3 into there. We just have to sub theta equals pi on 3. Okay, so alright, let's sub pi on 3 in, so that's 1200 plus 450 to take cos pi on 3 all over sine pi on 3. Okay, we should know that cos pi on 3 is cos 60 is half. We definitely should know that because that's how we knew cos theta was straight up half. Cos pi on 3 was half. And then sine 60 is root 3 on 2. So divide by root 3 on 2 equals 1200 plus 900 take 225 all over root 3 on 2. Now, to make this easy for myself, I'm just going to times the top and bottom by 2. It just makes it a bit easier. So basically what we have on the top is 2400 plus 1800 minus 450. And when you times the bottom by 2, it just gets rid of the divide by 2. So divide by root 3, which means that I have 2400 plus, or take away 450 is first of all 1950. Add another 1800 to that, and that's 2750. So that's 2750. No, I think I missed a. Be careful, be careful. So that was actually 1950. That's what that is, and then plus 1800. So that's 0, 5, 9 plus 8, 7. It's actually 3750 divided by root 3. And we can times top and bottom by root 3 to rationalize the denominator. And final answer is 3750 root 3 over 3 kilometers. That is the exact value of the minimum distance. It just says determine the minimum value of x. Okay, so pretty full on. A few spots that you could make silly mistakes, and the mental math was a little bit challenging. But yep, that's how we do that question. Okay, interestingly note, it was question number 9, which is the last question in the Calc Free for that exam. It even says end of that booklet. Okay, question number 3, differentiating E. We have to find the stationary points. Stationary points is when the derivative is 0, so that should be pretty straightforward. We obviously have, again, one function times by another function, so we're going to use product rule. Copy out the x squared, differentiate the second thing, plus the other way around. Alright, that is y dash. Alright, copied out one, differentiated the other, and the other way around. Make sure you remember how to differentiate e to the power of something. You just have to bring the derivative of the power to the front. So negative 4 came to the front, and we got that. Perfect, we've got to let that equal 0. So easiest thing to do is realize that we can factorize out an x, and we can factorize out e to the minus 4x. Both terms have an x common, and both terms have an e to the minus 4x common. In fact, both terms also have a 2 common. This says 2, this says 4. So what are we left behind with? That would be minus 2x, and over here it's just a straight up plus 1. So if this is 0, it means that either this is 0, or this is 0, or this is 0. So either x is 0, or e to the minus 4x is 0, or minus 2x plus 1 is 0. Now we should all know by now that e to the power of something cannot be 0. There's no solution over here. E to the power of something cannot be 0. So I guess that means that the answers are either x equals 0 is one of the answers, or 1 is 2x, x equals half. So the x coordinates of the stationary points are therefore x equals 0 and x equals half. Those are the two stationary points. All right, it says use the second derivative test to determine which of the point is a maximum and state the coordinates of this point. Okay, we have to find out which one is the max. Alrighty, and it says use the second derivative. So first of all, I hope everyone realized that we did have a nice simplified expression for the first derivative. Okay, there's a bit of a learning point in this. We did have a nice simplified expression for the first derivative. However, guys, this is like 3 terms. 1, 2, 3 terms. We don't want to, I don't want to do triple product rule. I don't even know how that exists. So what I'm going to do is leave the 2 at the front, but I'm going to bring the x back in. So if I bring the x back in, it's minus 2x squared plus x, and that makes it so much easier, okay? Because now it's one function times by another function, and when it's one function times by another function, we can just straight away use our normal product rule. So copy out 1, so I'm copying out 2e to the minus 4x, then I differentiate the other one, plus the other way around, copy out minus 2x squared plus x, and then differentiate this. That means we bring the minus 4 to the front, so that's going to be minus 8, and then copy it out. I will not simplify this. I will only ever simplify if I want the derivative to equal 0. We don't want the derivative to equal 0. We're just subbing points in. We're subbing in x equals 0 and x equals half. Now, I hope it's 0. That would make life very easy. So let's just sub 0 in. That would be 2e to the 0 times by 0 plus 1 plus minus, that's just 0, plus 0, minus 8e to the 0. It doesn't matter. Anything times by 0 is just 0. So this gives us just 2. Yep, just 2, because this is 1, this is 1, so we just get 2 plus 0, which is 2, which is a negative number, and therefore it is a max. What does the question want? Yes, that's what I wanted. Which of these is a local max? So we have now found out which of these is the local max. We had a choice. We had to try x equals 0 or x equals half, and then obviously x equals half turned out to be the x equals 0 is the easier one to sub in. Now let's just make sure the other one is a min. Obviously it's not required, but just as a secondary thing, I'm just going to prove that half was the min. So let's put half into here. It's a bit more complicated to put in there. Minus 4 times half is minus 2. That's minus 2 plus 1, plus the other way around. So it's a bit more challenging, you can see. Half squared is a quarter. Quarter times minus 2 is minus a half. Oh, we're lucky. We're just lucky again that when you sub it in, this bit here is 0. So then we don't even need to really simplify this bit here, even though it's that. So what do we end up getting? We end up getting minus 2. Remember, this is just 0. 0 times anything is 0. Minus 2 plus 1 is negative 1. We get negative 2 on e squared. Now, that is a negative number, and being a negative number, therefore it is a... I've just realized I've just been so dumb. If it's 2, 2 is not negative, 2 is positive, and positive means therefore min. Good thing I checked the other one. So again, be really careful. Don't make the silly mistakes I've made so far. But 2 is a positive number, whereas this is a negative number. Therefore, it is the max. All right, whoops. So at least I checked the other one. So there you go. I just don't know why I said 2 is negative. Perfect. And state the coordinates at this point. So we've just proven that this is the max. We want the coordinates, so we want to just put half back into the original function. So if I put half back into here, y to half squared is a quarter, e to the negative 2. All right, that's what happens when we sub half back in. Turns out that this was the less important thing and this was the more important one. Alrighty, and therefore we can basically say there is a max at x equals half, and then half, and then we simplify this to 1 on 4e squared. Okay, there is a max at this point here. Obviously, using your rules of indices, we could have brought e to the negative 2 to the bottom. Okay, I'm just going to check whether that's right. X squared e to the minus 4x. X squared e to the minus 4x. E to the power of minus 4x. And let's just f max that. Okay, so guys, if you get this, and remember, we don't even have boundaries to work with. So it turns out, the reason why we're getting this, by the way, I hope everyone realizes why we're getting it. So I've got no clue what this looks like. I've got absolutely no clue what it looks like. But if I was to just give you like a comparative example. So let's say you have a cubic. So if you have a cubic, obviously there is a max here. There is obviously a min here. But you can notice this cubic doesn't have boundaries, which means it goes all the way there, all the way there. So despite this being the local max, and despite this being the local min, you can notice the graph goes much, much higher and it goes much, much lower. In fact, when x is basically approaching infinity, you can see the y value, actually when x is approaching negative infinity, because this is to the left, when x approaches negative infinity, y is approaching positive infinity, and that's like your global maximum, and your global minimum is here. So it turns out that when x approaches positive infinity, y approaches negative infinity. So it turns out that the lowest point is not this. There's actually a lower point, and the highest point is not this. Turns out that there is a higher point, and that's what's happened over here. What's happened over here is we're getting a max value of infinity when x is negative infinity, just exactly like what I did. Unfortunately, there's no boundaries. Usually when we're doing optimization, there are boundaries to the question, but this question has got no boundaries, okay? There is no domain. Domain is all real numbers. So in fact, to find out the max of this, you have to put it on, I guess, graph mode, or differentiate and let it equal 0, just like I did. But if I was to put this in graph mode, clear all. Alrighty, great. And then graph it. Alrighty, and I know it looks funny. Zoom auto first of all. View window default, sometimes that does it, and can't really see much. Doesn't matter. Let's have a look, see how we go. Gsolve. Min is at 0, 0. We don't want the min. We want, oh, there you go. Min is at 0, 0. We did have a minimum at 0, did we not? Yes, we did have a minimum at x equals 0. And then let's just check our max. Our maximum value. Gsolve max. And there you go. It's at x equals half. And it's at this y value here, 0.0338338. What did we say our max was? That's the problem with graph mode. It doesn't give it to you exactly. We said that our max was at 1 on 4e squared. Let's just look at what is 1 on 4e squared. 1 on 4e squared is basically 0.25 e to the minus 2. That's what I had. And that, yep, same number, 0.0338338. Okay, so perfect. Okay, be careful, and I hope we learned something about the importance of graph mode, of how the f min f max cannot find local mins and local maxes. Okay, f min f max in main can only find global minimums and global maximums. Okay, all right. Next question. Actually, guys, you could have cheated a little bit. Okay, I'll show you what I actually now. This is kind of cheating. Okay, it's kind of cheating. So obviously we don't have boundaries, but this is a little bit cheating. It's not a very safe way of doing it. But hypothetically, you could just say, oh, from -5 to 5. I don't even know if it will work. Yeah, it doesn't work, guys. It still picks up one. So ignore the last 30 seconds. Don't worry about what I said. There is no safe way to do it other than to do calculus or to use graph mode to find local min and local max. Okay, determine the derivative of this. It doesn't say simplify, so we will not simplify. We just want the derivative. So what do? Quotient rule, copy the denominator. And then I always copy the denominator both top and bottom so I don't mess it up. Copy the denominator on the top, copy the denominator on the bottom, then differentiate the top. So that would be 6e to the 6x take 1 minus the other way around. All right, now we have to differentiate the denominator. We should all know derivative of sine is cos. Derivative of sine is cos. So that would be that. But then you also must multiply by the derivative of the angle. Derivative of pi take 3x is -3. And that's it. That's your derivative. It does not say simplify, all right? It does not say simplify, so I would not, if the question said simplified, which it does not, if it said simplify, I mean, there's very little you can really do. We can't even factorize this out because it's got to take one. Actually, sorry, this is over here. My bad. We can factorize out the e to the 6x take 1. Anything else I can factorize out? This one says 6, this one says 3. Okay, so I can factorize out 3e to the 6x take 1. What does that leave me with? A 2 and the rest of the sign. 2 sine pi take 3x. And then plus, because this is minus, so we're actually left with plus. And then cos pi take 3x. Perfect. So if you were asked to simplify, it is possible somewhat. And then all divide by the denominator squared, which we already have. That can't be simplified anymore. Cool. That's that. Next question. All right. Let f of x equal this. It has a stationary point when x equals -3. That's so easy. If it has a stationary point at x equals -3, it just means the derivative at -3 is 0. So really, really easy. Let's differentiate this. I'll write this a bit better. All right, f dash x is 5 take k on 2x to the -2, aka 5 take k on 2x squared. And remember, we know that f dash at -3 is 0. So 0 equals, and we just have to sub -3 into here, 0 equals 5 take -3 squared. -3 just crosses out, so it's just 9. 9 and 9 just crosses out, so we basically have, where did my k go? That's not a -3, that's a k. Okay, 0 equals 5 take k on 2x squared. F dash at -3 is that. That's easier. So basically we have k divided by 3 squared, 18 is 5. K is 90. Okay, k is 90, and that seems pretty good. Let's just check what happens when we sub 3 into here. 5 take 90 on 2 times 3 squared. 3 squared is 9, 9 2s are 18, 90 divided by 18 is 5. Yep, everything works out great. So the value of k is 90. All right, so that is the value of k. We know we have a stationary point, and now they want us to use the double derivative test to figure out whether it's a min or a max. So if I was to rewrite f dash x again, but replace the k, it is 5 take k on 2, so 90 on 2 is 45, x to the -2. That is f dash x, and we have to use the second derivative to determine whether it's a min or a max, or a horizontal point of reflection. 90 x to the -3, aka 90 on x cubed. We want to sub what into here? We're testing the point minus 3. We're testing the point minus 3. F double dash at minus 3. Now, you don't have to be very smart to realize this is a negative number, okay? Even if you didn't find out the entire number, that is good enough to write equals negative, and therefore max. Okay? Next question. A curve has got this equation. Find the stationary points. All right, find the coordinates of the stationary point. Again, we have one function times by another function. So let's differentiate. Using product rule, copy out one, differentiate the other one. What is the derivative of 4nx? The derivative of 4nx is 4n. And then we copy it out, plus the other way around. Great. So that's product rule, copied one, differentiated the other one, and vice versa. Now we want to let it equal 0. What do you do when you want to let the derivative equal 0? You always simplify. So to simplify this, we can factorize out the 3 and the e to the 4nx. That leaves us with, if you took out the e and 3, so that leaves us with x, 4x actually. That leaves us with 4x over here. 4xn over here. It leaves us with 4xn. And what does it leave us with over here? Just a plus 1. Perfect. So that is y dash. We've got to let y dash equal 0. 4xn plus 1 equals 0. We already discussed e to the power of something cannot be 0. That means 4xn plus 1 is 0. That means x is minus 1 on 4n. That is, guys, the x value of the stationary point. It said coordinates, which means we need to find the corresponding y value. So we have to put minus 1 on 4n into the original equation. 3 minus 1 on 4n. So instead of x, we write that. And then e to the 4n minus 1 on 4n. Equals minus 3 on 4en. Okay, lots of spots for silly mistakes. Lots and lots of spots for silly mistakes. The coordinates of the stationary point, minus 1 on 4n. And minus 3 on 4en. Obviously, the n just made everything confusing. That is the coordinates of the stationary point. I don't even know if that's the min or the max. Let's have a look. 3x e to the 4nx. 3x e to the 4nx. X. Okay, that's what we had. I don't even know if that was the min or the max, so let's just check. F min, F max. I don't know if it's the min or the max. Oh, that looks familiar. Minus 3 on 4en and minus 1 on 4n. So I just got lucky. I don't know if it was a min or a max. That's my way that I would check if it was classified aloud. Minus 3 on 4en, and that's exactly what we wrote. We wrote minus 3 on 4en is the y value, and the x value is minus 1 on 4n. You can see that, yes, x is minus 1 on 4n. Okay, so making sure I didn't make a careless error. Determine the coordinates of the point of inflection if n is 1/8. All right, if n is 1/8, we want to find out the coordinates of the point of inflection. So first thing first, that was our derivative, but we now know that n is 1/8. So if n is 1/8, 4 times 1/8 is just 2. Oh, sorry, half. 4 times 1/8 is half. And then this is 4 times 1/8 is half x plus 1. That's a derivative. If you want points of inflection, we want when the double derivative is 0. So let's differentiate that one more time. Again, product rule. It's one function times by another function. Copy out the first function, differentiate the second, plus the other way around. Copy out the second, differentiate the first. You just had to bring the half out to the front, so it's 3 on 2, and then copy it out. Perfect. I don't let that equal 0. I don't simplify that because, oh, sorry. Take that back. I do simplify that. I want to let the double derivative equal 0. If the double derivative is 0, we always simplify. So what do these two have in common that I can simplify out? They both have a 3 on 2 and a 3 on 2. So I'm just going to highlight what they have in common. 3 on 2, 3 on 2. They both have a e to the half x and a e to the half x. So we have 3 on 2 e to the half x. What are we left behind with? For the first thing, nothing. We just basically factorize the entire thing out, so we're left with a 1. And the second one, it's plus half x plus 1. Okay, so 3 on 2 e to the half x. 1 plus 1 is 2. And we have to let that equal 0. Now, we already discussed e to the power of something cannot be 0. So the only bit that's 0 is this bit here. 2 plus half x equals 0. X is minus 4. Alright, now I just have to put minus 4 into the equation. Now, what was the original equation? The original equation was y equals 3x e to the, remember, n is 8. So, sorry, n is 1/8. So 4 times by 1/8 is half. So we have to put that back into the original expression. Okay, let's see what happens when I put it back into the original expression. The y value at 1/8 is 3 on 8. E to the power of half times 8 is 1 on 16. X is, I don't know why I'm putting 1/8 back in. We're putting 4, negative 4. Okay, we got x equals minus 4. At minus 4 is minus 12. E to the half times minus 4 is minus 2. Minus 12 on e squared. Alright, therefore, there is a point of inflection at minus 4, minus 12 on e squared. Now, again, this is calc free, so you just have to make sure that there was no careless errors that you made. If it was calc assumed, a couple of things you can do. If it was calc assumed, first thing you can do is we'll replace the n with 1/8, so that's 0.5. I mean, obviously, if it's calc assumed, the most obvious thing you can do is differentiate it twice. Calc diff, that's diffing it once, and let's diff it again. That's differentiating it again. And then I just write solve and so that will just let it equal 0. And there you go. You get x equals minus 4. That's exactly what we got. Then you get the original expression. And then you put x equals minus 4 into there. And minus 12 on e squared. What did we get? Yep, minus 12 on e squared. Okay. Be very good at not making careless errors. So even if you make a careless error, you can see every now and again I do make a careless error, but I still somehow pick it up. There's some clue, something somewhere that often helps me pick up a careless error. By the way, something that a lot of people don't know you can do. So obviously, guys, when you do interactive calculation, that's all the options that you have. But there's something pretty cool you can do on graph mode. So let's get the original function. Now remember, guys, we were looking for points of inflection. So if I go on graph mode is pretty good. It actually finds points of inflection as well. All right, often finds points of inflection. Analysis, gsolve, and then you can see it says inflection. There you go. You get an x value of minus 4. The only problem is the y value is not exact. Okay, so it's minus 1.624023. And then if I was to change this into decimal, same thing, minus 1.624023, etc. Okay, graph mode can find points of inflection for you. Question number 5. Determine the coordinates of the stationary point of this graph. All right, you can see, guys, almost every single question in most semester 1 and semester 2 exams for optimization relate to sine, cos, or e. Okay, lots relate to sine, cos, or e, especially in the calc free. All right, stationary point, copy out one, differentiate the other one. Now, how do you differentiate e to the power of something? You bring the derivative of the power to the front, plus the other way around. Okay, are we trying to let it equal 0? Yes, we are. We're trying to find out when f dash is 0. Since we're trying to let it equal 0, it is best to simplify. Anytime you're letting the derivative equal 0, it is best to simplify. So what we could do is factorize out, again, let's see what they have in common. They both have a minus 2, so that's good. We can take that one out, and they both have an e to the minus 2x, e to the minus 2x. So we can take out minus 2e to the minus 2x. That leaves us with 1, take 2x plus 1. So minus 2e to the 2x, 2 take 2x. And we're trying to find out when f dash x is 0. Now, obviously, e to the power of something cannot be 0, so it's the second bit that has to be 0. 2 take 2x is 0, x is 1. Okay, so far so good. That's a nice value to be subbing in, and it's worth 6 marks. Okay, it is worth 6 marks. So we have to determine the coordinates of the stationary point. All right, if I want to work out the coordinates of the stationary point, I need to put that into the original function. So f at 1, that should be so easy. That's 1 take 2, e to the minus 2, aka minus 1 on e squared. All right. We also need to do the double derivative test because it says determine the nature. All right, I need to differentiate this one more time. So if I differentiate it one more time, again, I have to use product rule because it's one function times by another function. Okay, copy out the first, differentiate the second, which would just make it minus 2, plus the other way around. Copy out 2, take 2x, and differentiate the other one. So differentiate that, that's minus 4e to the 2x. Now, generally, guys, I would not simplify this. Why would I not simplify this? Am I trying to let this equal 0? No, I'm not. I'm just using the second derivative test to determine its nature. But hopefully in reading time, you notice that later on, they want the point of inflection. So they do want a point at which the double derivative is 0. So just to help myself out, I will simplify this. All right, what do they both have in common? They now have a... They both have a 2e to the 2x and a 2. So that's basically, that's a 4e to the 2x. And here's 4e to the 2x. So we're basically factorizing out 4e to the 2x. Now the minus times by minus just becomes a plus, so we're left with plus 1. And over here we're left with 2 take 2x. Actually, no. We're left with a minus here. Again, be very, very careful not to make careless mistakes. We're left with a minus here. So it's not 1 plus this, it's 1 take 2 take 2x. All right, that's 4e to the 2x and 2x take 1. Perfect. So what is f double dash at 1? We need to put 1 into here. So that's 4e to the 2. I've just realized something. You've got to be so careful. All right, I've just dropped a negative. All right, again, I was realizing, why is this e to the negative 2, but I have now e to the positive 2. So when I differentiated, there you go, it's right here. It's because I used this line of working. So see, even when you copy the next line of working, there are rooms for careless error. So minus there, and that will change a few things actually. So I'm just going to play that fresh. If I make a silly mistake, I usually rub it out because I don't want to carry that mistake through. Copy out one of them. Differentiate the other one. So that's minus 2 plus the other way around. Copy out 2 take 2x and differentiate this. So when the minus 2 comes to the front, it becomes plus 2. And then copy it out. There you go. That's doing product rule properly. Copy out one, differentiate the other, plus the other way around. Again, I'll simplify that. What do they both have in common? E to the minus 2x, e to the minus 2x. They have 4 in common. Minus 2 times 2 is 4. So if I factorize out 4e to the minus 2x, what am I left with? I'm left with 1 plus. This time it is plus because there's no minus over here. So it is 1 plus 2 take 2x, aka 3 take 2x. Perfect. That is a double derivative. Let's put 1 into there. So that's 4e to the minus 2. And then 3 take 2 is 1. We're left with 4 on e squared, which is a positive number. Therefore, min. So basically what we can say, guys, for 6 marks, therefore, there is a minimum at an x value 1 and a y value at 4 on e squared. Okay? 1 take 2x, e to the minus 2x. 1 take 2x, e to the minus 2x. 1 take 2x, e to the minus 2x. Cool. Alrighty, let's just check whether we're all right. So sometimes, again, this can only be done in calc assumed, otherwise you just have to be careful. So we even said it was a minimum, right? So f min, and there you go. Yep, x equals 1 at minus 1 on e squared. What did we say? We said x equals 1. Uh-oh, there's a 4 there. There's a 4 there. Did I copy that right? 1 take 2x. 1 take 2x, e to the minus 2x. Yep. I'm just being silly. Just be really careful. Be alert. All right. This is the double derivative. That's not the y value. The y value is right here, minus 1 on e squared. So I did everything right, but again, copied it out incorrectly. Okay. So, yes, there is a minimum at 1, minus 1 on e squared. That's what we got, 1 at minus 1 on e squared. Perfect. All right, next part. Luckily, I did find the double derivative nicely. I found the double derivative very nicely. I found a nice simplified version of it, which makes this easy to do. F double dash at x is this, and we want to let it equal 0. If you want this to equal 0, as we've discussed several times today, e to the power of something cannot be 0. It must be the next bit that's 0. 3 take 2x is 0. X is 3 on 2. We need to put 3 on 2 into the original function. 1 take 2 times 3 on 2 is 3. E to the minus 2x. 2 times 3 on 2 is again 3. That gives us minus 2 on e cubed. Perfect. Minus 2 on e cubed. Determine the coordinates of the point of inflection. So yes, therefore, there is a point of inflection at 3 on 2 minus 2 on e cubed. Three on 2 minus 2 on e cubed. Let's just double check. That was the original function. I hope everyone realizes that you can actually double diff quickly. All right, so in math 2, I know everyone usually presses this button, but there's this button here. So if you were to write in here d squared, it does the double derivative for you straight away. So that's the double derivative. Now remember, what did we want the double derivative to equal? We wanted the double derivative to equal 0. So if you let the double derivative equal 0, solve ants equals 0. Yes, you get x equals 3 on 2. And then if you put 3 on 2 back into the original function, given x equals 3 on 2 minus 2 on e cubed. Is that what we got? We did get minus 2 on e cubed, and we did get 3 over 2. So if you got that, really, really good. Okay? Nice question. Typical question. All right, carrying on with the differentiation assessment by topic calc free. All right, question 8. This is a tricky question, all right? It would be really good if you pause at this point and try it by yourself, okay? Pause and try it by yourself. It is a tricky question. All right, let's see how you went. Determine f of x, so there's a function f of x. Determine f of x and f of x plus change in x when x is 61 and change in x is 4. All right, so f of x when x is 61, basically it means they want f of 61. So f of 61 is 61 on 61 plus 7, which is 61 on 68. Perfect. So that's that. And then we want f of x plus change in x, which basically means they want f of 61 plus 4, which means they want f of 65, which basically is 65 on 65 plus 7, which is 65 on 72. Perfect. A lot of people didn't even get part A because they didn't know what the question was asking for. Now, part B is a tricky one. I hope everyone's paused and tried it once by themselves. Now, they want us to use the function and the increments formula to estimate the difference between these two. Now, the first thing that I do is I think that, well, surely part B is related to part A. But then this and this look nothing like that and that. So, turns out part A doesn't really help. So what are you meant to do? All right, you just have to see it, guys. You just have to realize that, hey, look, this bottom number is 7 more than the top. This bottom number is 7 more than the top. It's basically in the form x on x plus 7. And then you're meant to realize that, hey, x on x plus 7 is just your original function. And then if you realize that, things will start to click. So what you have realized straight away is that, okay, this is this. I just have to realize what x is. And you don't have to be very smart to realize that, okay, f of 73 is basically 73 all over 73 plus 7, aka 73 on 80. So that's f of 73. And then you're meant to realize that, all right, f of this one here is 75. F of 75 is 75 on 75 plus 7. And that is 75 on 82. That is 75 on 82. All right, what do you guys notice? So I used f of x, and I hope everyone noticed that using f of x, there has been a small change in the x value. And if there's a small change in the x value, there will also be a small change in the y value. Ah, that's what the question is asking for. They want the difference between these two things, and they want us to estimate the difference. So basically, effectively, they just want the change in the y value. Whatever the change in the y value is the difference between 73 on 80 and 75 on 82. So if you realize that, now the rest of the question is quite straightforward. The change in the y value is approximately, we all know the formula, dy on dx times change in x. All right, so let's just work out what dy on dx is. Now we know the original function is x on x plus 7. So I just have to differentiate this. Copy the denominator, differentiate the numerator, minus the other way around. Which is basically x plus 7 take x on x plus 7 squared, which is basically just 7 on x plus 7 squared. Perfect. So for the derivative, I can write x on x plus 7 all squared times by the change in the x value, which was, how much did the x value change by, guys? It went from 73 to 75, so the change in the x value was clearly 2. The change in the x value was 2, and the change in the y value is the question itself. That is the question. Find out the change in the y value, aka the difference between those numbers. Okay, so change in the x value is 2, and when did we change it? At x equals 73. So now all I need to do is sub 73 into there. 73 on 73 plus 7 squared times by 2. That's 73 times 2. All over 73 plus 7 is 80 squared. 80 squared is 80 times 80. All right, simplify that. So that simplifies out nicely. 2 and that becomes 40. And that is it. So my best estimate for the change in the x value is 73 on 8 4s at 3200. 73 on 3200 is the approximate difference between those two values. Not too bad if you realized it, okay? But they didn't give you much clue, and then part A was a bit of a distraction because part A didn't really help. It would have been better if they said find it when, it just would have made so much more sense if the question said when x is 73 and the change in x is 2, because that would have explicitly, if it was 73, you would have explicitly got 75 on, for the first term, you would have got explicitly 73 on 80. That's what you would have got. And you would have explicitly got 75 on 82, and then you would have just realized that, oh, we just want the difference between these y values, okay? And if you want the difference between these y values, you know exactly what x value to sub in and what the change in the x value is. But they just gave different numbers just to make it a bit harder. All right, nice, easy question. Find the derivative. It does not say simplify, hence we will not simplify. So I'll just rewrite f of x a bit nicely, and then we just use chain rule. Bring the power to the front, decrease the power by 1, multiply by the derivative of the bracket. Again, you would not simplify in a test, okay? I'm only simplifying if it made you, but in a test you would not simplify. So 2 on 4x take 3 to the half. That is pretty good. And if you really, really wanted to, and there is no requirement to, even if it said fully simplified, there's no requirement to, but you can change that back into square root. I know some teachers say that if the question is given to you in square roots, you give the answer in square roots, but not in SCASA, okay? Not for WACE anyway. All right, we have to use product rule. So first we have to find the derivative. So the derivative, straight up, again, using product rule because we have one function times by another function. Copy out the theta cubed and differentiate that. So that's 4e to the 4 theta plus the other way around. Copy out e to the 4 theta and differentiate theta cubed. That's 3 theta squared. I know it's a bit weird because we usually don't have theta by itself, but that was pretty easy. Product rule. And when do they want it? When theta is 2. They want d on d theta at theta is 2. Equals 2 2s are 4 2s are 8. 4e to the theta is 2, so that's 8 again. Plus e to the 8, and 2 squared is 4. 32e to the 8 plus 3 4s are 12e to the 8. So the final answer is 44e to the 8. Perfect. Next question. They want the derivative at pi on 4. So let's just work out the derivative by itself. Quotient rule, copy the denominator on the top, copy the denominator squared on the bottom. All right, I always do that straight away. All right, always do that straight away so don't mess up the order. Denominator and denominator squared. Okay, the top derivative cos is minus sine t, and then minus the other way around. All right, so then now I just do copy out the 1 plus cos t and differentiate sine t to be cos t. Perfect. So that's the first step. I guess I will simplify, it might help. Minus sine squared t minus cos t minus cos squared t. Be careful, the minus carries on, okay? It would have been easier if you wrote the cos here. All over sine squared t. Now, if someone's really, really, really switched on, they'll notice that they have a minus sine squared t, take cos squared t. If you have minus sine squared t, take cos squared t. Everyone knows that we discussed it earlier, that sine squared t plus cos squared t is 1. Which means minus sine squared t minus cos squared t is minus 1, okay? So those are things that just help. So knowing that helps. If you didn't know that, no big deal, all right? No big deal. When you sub in the pi and 4 and sub in the pi and 4, you'll eventually simplify out to give 1. Just for argument's sake, I will sub in the pi and 4, even though that's not what I would have done in a test. It's minus sine pi on 4 squared. You know what? I'm not doing it. I would have just realized it's 1. So that's minus 1. We want to take away cos t on sine squared t. All right, make life easy for yourself where you can. Great, we want f dash at pi on 4 or 45 degrees. So that's minus 1. Take cos 45 degrees. So cos 45 is 1 on root 2. Or root 2 on 2, depending on how you want to write it. Cos 45 is root 2 on 2. And on the bottom, sine 45 is 1 on root 2 and squared. Notice I'm not writing root 2 on 2 on the bottom. I'm not writing root 2 on 2 on the bottom because when I square it, the root will disappear. All right, so that gives us minus 1 on root 2 on 2 and divide by half. And everyone knows, everyone knows that divide by half means times by 2. So the final answer is this. 2 take... All right, I just changed my divide by half times by 2 on 1. And then I guess that simplifies out to 2 take root 2. Perfect. That is f dash at pi on 4. Next question. All right, determine the interval over which the first derivative is 0 and the double derivative is less than 0. All right, 5 marks. First thing first, we're told there's a stationary point here, so that helps. There is a stationary point here, so that means that f dash at -1 is 0. Remember, not 2. 2 is the y value, and we only have the derivative, so let's use that first. So f dash x equals ax squared plus 4x plus 6. So if I sub -1 into there, we know that f dash at -1 is 0. So 0 equals a times -1 squared plus 4 times -1 plus 6. A is -2. Perfect. A is -2. And now that I know that, that should help. I want to find out, first of all, when the first derivative is more than 0. So I want to find out if f dash x is more than 0. We want to find out when is -2x squared plus 4x plus 6 more than 0. Remember, we have two different facts. I'll just do them in different colors so we don't get confused. I'll just say we have green fact and we have red fact. So let's work with the green first. The derivative has to be more than 0. So if the derivative has to be more than 0, guys, now I'm going to times everything by negative. I'm going to divide everything by -2. And we should all know that with inequalities, if you multiply or divide by a negative number, you flip the sign. So that's less than 0, aka x take 3, x plus 1 less than 0. So if I was to draw a parabola, the two roots for this are -1 and 3. The two roots for this are -1 and 3. And when is this parabola, when is this happy face parabola less than 0? The happy face parabola is less than 0 between -1 and 3. Alright, so between -1 and 3, the derivative is less than 0. So let's just write that down. Somewhere between -1 and 3. On top of that, we want the double derivative to be less than 0. Okay, so we know what the first derivative is. The first derivative was this, minus 2x squared plus 4x plus 6, which means the double derivative is minus 4x plus 4. And now we want the double derivative of x to be less than 0. We want minus 4x plus 4 to be less than 0. Okay, so minus 4x less than minus 4. Again, I'm dividing both sides by a negative number. So if I divide an inequality by a negative number, I must flip the sign. Alright, so I have x more than 1. Alright, those are my two requirements. I'll draw it on a number line for those that can't visualize it. Okay, I'll draw it on a number line for those that can't visualize it. So I've got a -1 somewhere, a 1 somewhere, and a 3. Requirement number 1 is that it's between -1 and 3. Requirement number 1 is that it's between -1 and 3 with hollow dot, hollow dot. Alright, not inclusive. Requirement number 2 is that x is more than 1. Alright, where do these two overlap? They overlap right here. That is where the overlap is. So therefore, the final answer is both criteria satisfied if it's somewhere between 1 hollow dot and 3 hollow dot. So the answer is between 1 and 3. Not bad for 5 marks. You had to remember your quadratic inequalities and linear inequalities from previous years. Next question. Alright, functions f and g are such that blah blah blah. Determine f of, okay, I'm not going to do part A because it's integrating, okay? Part A is integrating, so we don't need to know how to integrate for this. However, we will do the next question, okay? We're not doing part A because it's integrating to find f of 6, but we will do part B, which is using the incremental formula. So we want to work out the g value at minus 3.98. Now, everyone agrees that would be an absolute nuisance to sub minus 3.98 into here. We just wouldn't, well, first of all, you'd have to work out f of the function, and we don't even have f of the function. So how do we find out g of minus 3.98? What you have to realize that, hey, that's very close to g of minus 4. Surely it's very close to g of minus 4. We know what g of minus 4 is. We know g of minus 4 is 2. That's what the question explicitly says. G of minus 4 is 2. However, what we are doing is, I hope everyone agrees, there has been a change in the x value. Change in the x value of 0.02. We have added 0.02 to it. And if there's a change in the x value, surely there should be a change in the y value. And what do we know is our formula for change in y value? dy on dx times change in x. In this particular case, it's g dash of x times change in x. Now, what is g dash x? The question tells you straight away. 18 on 3x plus 10 squared. It is 18 on 3x plus 10 squared. All right, times by the change in x. The change in x was 0.02. That should be easy. Where do we change it? When x was neg 4. So we just sub negative 4 into here for x. 3 times neg 4 plus 10 squared times 0.02. All right, equals. Okay, so 3 times neg 4 is negative 12. Negative 12 plus 2 is negative 2. And instead of writing 0.02, I think it's just going to be easier if I write 1 on 50, I think. So we have 18 divided by negative 2 squared, it's 4 times 1 on 50. All right, let's simplify that. So 4 becomes 2. That becomes 9. Oh, that's so easy. We get a nice number of minus 9 on 100, sorry, 9 on 100, which is basically 0.09 exactly. Okay, so apparently the change in the y value is 0.09. So what I'm trying to say, guys, is the g value at minus 3.98 is whatever the g value used to be at negative 4 plus the change in the y value. So that would be 2 plus 0.09, and that is 2.09. That, guys, is your approximate value of g of minus 3.98. Okay, now, just a thing that we should know, guys, a thing that we should know. If you want to find out the exact change in y from x1 to x2, the formula is integral from x1 to x2 of basically the derivative, so dy on dx, times change in x. That will give you the exact change in the y value, and it can be any change in the x value. You can have any x values here. However, if you want the approximate change, in the x in the y value from x1 to x2, if you want the approximate change, it is approximately the formula that we've just been discussing, dy on dx times change in x, okay? Over here I was meant to say dx. We have one formula for the exact change and one formula for the approximate change. But guys, this formula will always work. So this one always works, okay? Always works. This one only works if it is a small change in the x value. If it is not a small change in the x value, it is not a reliable approximation, okay? So, for example, over here, the change was from negative 4 to negative 3.98. That was a very small change, all right? Which means the formula is reliable. Now, I'm just going to show you, by the way. I'm going to show you how would we have found out the exact change in the y value. You could have found out the exact change in the y value. I'm just going to use the formula for the exact change, and equals to exactly, all right, what did we change it from? Minus 4 to minus 3.98, right? So minus 4 to minus 3.98, and then for the derivative, what did we have for the derivative? Integral of the derivative, which was 18 on 3x plus 10 squared. All right, so let's see what the class pad would have spit out. All right, so this is for the exact answer, 18 on 3x plus 10 squared. And from, what was it, from minus 4 was the initial value to minus 3.98. This will give you the exact change. 9 on 97, aka 0.09, 278. Now you can see that we were kind of close. We got 0.09 as our approximate change, whereas the exact change was pretty much that, 0.09278. All right, 0.09278. Not bad, okay? So this is the exact change in the y value. All right, now, so it says briefly discuss whether using the information given about f, would we be able to yield a reasonable approximation of f of 6? Now, what do we have currently? We have f of 4. Now, guys, jumping from an x value of 4 to an x value of 6 is not a small change. So you can write a change in x. A change in x from 4 to 6 is not a small change in the x value. Yeah, you've basically, it's like 50% more. Therefore, you can basically say it's a 50% increase. Therefore, the incremental formula is not reliable. The incremental formula would not be reliable to even approximate f of 6. It only works, guys, for very small changes. The bigger the change, the less reliable it is. All right, there's no magic point at which you can stop. Just the further away, the bigger the change, the less reliable it is. Alrighty. Next question. This function is this. Determine the coordinates and nature of stationary point, 7 marks. Okay, luckily they gave us the double derivative. So first thing we have to do is just find out the first derivative. They've given us the double derivative and they've given us the original function. So the first derivative, quotient rule, copy the bottom. I always copy the bottom twice. Differentiate the top, minus the other way around. X squared take 3, differentiate the bottom. All right, I will simplify that because I need to let it equal 0. So if I simplify it, there's nothing I can factorize out really. So I just accept minus becomes a plus. So we have 4x take 2x squared plus x squared take 3 all over 2 take x squared. That gives us minus x squared plus 4x plus 3 all over 2 take x squared. That is f dash x. Now, we want to find out when it's equal to 0. When a fraction equals 0, which part is 0? The numerator is 0. I'll times everything by -1. And this is quadratic. So what numbers multiply to give -3, but add to give -4? Make sure I've just done that right. 4x take 2x squared. Yes. Oh, whoops. Minus becomes a plus, but this is still x squared plus 3. You'll notice, how do I know I made a mistake? I realized that I can't factorize this properly. I don't know any numbers that multiply to give -3, but add up to give -4. So then that made me go back and realize that it's calc-free. I must have made a careless error. So this should be x squared take 3, x squared take 3. Okay, that's better. X squared take 3, which makes this plus 3, which makes this so much easier. What numbers multiply to give plus 3 and add up to give -4? And that would be -1 minus 3. X is 1 or 3. All right, determine the coordinates. All right, so to find the coordinates, I have to put this back into the original function. So what is, first of all, f of 1? 1 take 3 on 2 take 1. That's -2 on 1, which is -2. And then we also have to put 3 into the function. 3 squared is 9, take 3, 6 on 2, take 3. 6 on -1 is -6. Okay, great. So now I've got some y values for them. Now I also have to find out their nature, so I need to put it into this equation. So f double dash at 1 is 2 on 2 take 1 cubed, which is 2 on 8, which is a positive number. And f double dash at 3, 2 take 3 cubed, that's 2 on -1, which is a negative number. All right, that's all I needed. So what does positive mean? Positive means therefore min, and negative means therefore max. That's all I needed. So not bad for 7 marks. All right, so therefore we have, all right, 1 neg 2, what was 1? A minimum. Therefore there is a min, a local min, at 1 neg 2, and a local max at 3 comma corresponding y value was neg 6. All right, I'll just double check, okay? But again, if we trust ourselves, we should be okay. X squared take 3 on 2 take x. X squared take 3 on 2 take x. All right, GSOL, where's our min? Yep, we have a min at 1 neg 2. And we have a max at 3 negative 6. All right, max at 3 negative 6 and min at 1 neg 2. Now, there's something really important that I want to show you. Now, a lot of people would have done this. A lot of people would have just thought that, all right, so this is a very important thing for people to notice. It's why the value test doesn't work. A lot of people would have thought that, why do I need to do the double derivative test? What's the point? A lot of people would have thought that, okay, if f of 1 is negative 2, so roughly, guys, if f of 1 is neg 2 on this scale, I would have just done this. F of 1, neg 2, somewhere around about here, that's 1 neg 2. And f of 3 is negative 6. If f of 3 is negative 6, I'll just move this all across. This is meant to be an axis, okay? X-axis, Y-axis. So then a lot of people would have thought that, all right, if f of 3 is negative 6, which is somewhere around about here, roughly. Okay, so a lot of people would have incorrectly done what we call a value test, and they would have just thought that, all right, well, that's the min and that's the max because this value is higher than this one. So now a couple of things. I want to show a couple of things about this and about why it would be wrong to assume that. I know common sense suggests it should just be this. It should just be a max at this value and a minimum by the time we get up to that neg 3 mark. I know that's what common sense would suggest. Okay, that's what common sense would have suggested. However, we clearly saw that 1 neg 2 was the min and 3 neg 6 was the max. So this would be obviously wrong. How is it wrong? How can it pass through there and through there, but how can this possibly be the min and how could this possibly be the max? Now, there is a very clear reason why that happened. The very clear reason why that happened is this. It's because, if I draw that again, it's because, if you have a think about it, there is nothing stopping you from doing this. There is absolutely nothing stopping you from having a min like such at 1 neg 2, as I've discussed, and then having a max at 3 neg 6, and then maybe there is just an asymptote in the middle. So the graph's basically approaching the asymptote here and asymptote here, and therefore it is possible. And in fact, that's exactly what happened. Because you have a 2 take x in the denominator, there is an asymptote at x equals 2, and that's why the minimum has actually got a higher value than the maximum. And by the way, guys, just because it passed through here, remember, it could have easily, just because it passed, even if you did use the value test, a lot of people think that, oh, as long as there's no asymptote, I can use the rule. All right. A lot of people think that as long as there's no asymptote, then the higher y value is the max and the lower y value is the min. That's not true. What if the graph had a horizontal point of inflection here? Then that's, you would have thought it's about to turn, but it actually goes the other way. Same thing over here. What if the graph had a horizontal point of inflection here? So what I'm trying to say is checking the y values is not a good test to check if it's a min or a max, okay? To check for a min or a max, the only proper tests are the sign test and the double derivative test, okay? So hopefully everyone learned something there, and this one is not a cross. This is actually what happened in this question. So this is what happened. So this just shows the importance of not relying on the value test, not relying on the y values, but actually using the sign test or the double derivative test. Well done.